In order to get more comfortable with matrix vector multiplication, it's useful to look at two different interpretations of the process. One is to interpret A times X as a linear combination of the columns of A. Let's see how this goes. Let's take combinations of the columns of A, each weighted by the corresponding value of X. There's the first column of A, scaled by X1. The second column of A, scaled by X2. The third column of A, scaled by X3. And so on. And finally, the mth column of A, scaled by Xm. Now, add these vectors up component-wise to give this expression, which is exactly what we defined as matrix vector multiplication. Therefore, matrix vector multiplication can be thought of as forming linear combinations of the columns of A, and the scalings on the columns are provided by the components of X. There's another interpretation where AX is interpreted as a vector of linear combinations of the entries of X. Let's see how that goes. On the left, we've notated the matrix vector multiplication, and on the right is the definition of that quantity. Now let's see a way to interpret it. Let's see how the first entry of the product AX arises. A11x1 plus A12x2 plus A13x3 plus A1mxm, and that is the first entry. It's a linear combination of the entries of X. How about the second entry of AX? A21x1, A22x2, A23x3, A2mxm, and that's the second entry. Also a linear combination of the entries of X. Any arbitrary row, follow the same procedure, and you'll get a linear combination of the entries of X. Finally, the last row, an1x1, an2x2, an3x3, anmxm, there's the summation, a linear combination of the entries of X. Hence, AX can be thought of as several different linear combinations using the entries of a row of A of the entries of X. Contrast that to the previous slide, which showed that AX, which is a column vector, can be interpreted as linear combinations of the columns of A. And that's very apparent here as well. Here's a column of A times X1 plus a column of A times X2 all the way over to the mth column of A times Xm.